One of the great things we're going to get a chance to do is build out NSX routers. But our NSX routers come in a couple of different flavors, and it can be challenging to understand exactly what the benefit of an NSX router is compared to a physical router, or to differentiate between the different types of routers that we have within NSX. By the way, hairpin turns and trombones will have a role to play in the answer. So in this nugget, we're just going to focus in on those key benefits of creating an NSX logical router. So to focus on routers, let's draw out a little network topology right now. Now with just this configuration in front of us, let's think about what would happen if we had virtual machines that belonged to a particular VLAN, let's say VLAN 25, and other virtual machines that were associated with VLAN 30. How could these virtual machines talk to one another? Well, in order to do so, they would have to send their request to their default gateway. And their default gateway would be out here because our physical network, our layer 2 switches, would also have to support VLANs 25 and 30. And so the virtual machine would forward through the virtual switch onto the physical switch, onto the multi-layer switch, which is aware of VLANs 25 and 30 and has an interface in both of them. And so it would receive a message in VLAN 25, but then it would send a message in VLAN 30, forwarding the frame into the correct destination network, working its way all the way back to the virtual machine that is the intended destination. So this out and back process happens every time we need to have communication between two virtual machines that are on different VLANs, even if they happen to be hosted on the same ESXi host. And that process is known as tromboning or hairpinning. And in both cases, we're just looking at this shape saying, man, that just doesn't seem very efficient, does it? So let's see how NSX routing is going to improve this process and make it all a lot more efficient. First, we're going to have to create some NSX switches. Now at this point, the virtual machines that are plugged into VXLAN 5001 or 5002 have access to all the other virtual machines in the same VXLAN. Even if they're on different ESXi hosts, it doesn't matter because the physical network is now just a transport network. And we're focusing on the interfaces of ESXi connecting into those switches as endpoints, specifically VTEPs. But now we run into the same issue that we had before. What if a device in VXLAN 5001 needs to communicate with something in a different subnet, something in VXLAN 5002? How can that happen? And by default, it can't. But we could add another NSX component to provide that functionality. And the object that we're going to add is what's called a DLR, a distributed logical router. That DLR can have interfaces in one or more VXLANs. Because it's distributed in the same way that each of our ESXi hosts has a little bitty 5001 switch built into it and a VXLAN 5002 switch built into it, because they're in the same transport zone, they're also going to now share a distributed logical router. It's as if each one of these hosts had an extra adapter plugged into that VXLAN switch in order to support the routing between the virtual machines in one node and the virtual machines in another. By virtue of the shared information shared from our control cluster, all the ESXi hosts will have the information necessary to route packets from any VXLAN to any other VXLAN within this transport zone. If this is all that we configured, there's going to be one other element that we're going to need to provide if we want those virtual machines to be able to contact the quote-unquote real world, and that is to provide support for what's known as layer 2 bridging, which essentially allows a VXLAN to have an on-ramp to a standard VLAN. In a logical sense, that means that our distributed logical router will need to have an interface to hook up to the physical routing infrastructure, typically beginning with that multi-layer switch. Logically, it looks like this. Physically, of course, each ESXi host is going to have a connection that is going to be associated with a VLAN that can work its way up to that switch and continue to provide routing. And in fact, a DLR is really only good for two things: routing and layer 2 bridging, which is what we just described. But there's another type of NSX router that we have to throw into the mix, and that's creating an edge router. This bottom ESXi host is going to represent the management cluster. In this case, what we're going to build on it is what's known as an edge router, which means it's really just a virtual machine that provides routing services. So why build a VM that provides routing when I have a router now distributed across all of my ESXi hosts, and I still have my physical routing that I can uplink to? By installing an NSX router, we're going to have a more advanced router. Yes, it can perform routing, but it can also perform network address translation. It can perform load balancing. It can function as a stateful firewall. It has several VPN services, and it can provide DHCP and DNS relay services. So what we see from this is that the DLR is really designed and positioned to support east-west routing, which is referring primarily to its ability to route between VXLANs in this case, whereas our edge routers are positioned for performing north-south routing. Another way to think of it is as a perimeter router. So once all of our routing infrastructure is deployed, if a virtual machine in one VXLAN needs to communicate with another virtual machine in a different VXLAN, but on the same ESXi host, that process can go through the distributed logical switch to the distributed logical router and forward that message. We never touched a physical interface. That all was in the processor of that first ESXi host. Now, if we needed to do the same thing, but it involved multiple ESXi hosts, we would perform VXLAN encapsulation, but the result still never involved touching a physical router. We never had to contact a network administrator to support our routing infrastructure. Neither do we need to contact the physical router administrations when we want to perform actions like network address translation, load balancing, firewall, VPNs, so on and so forth, which is key to why we're leveraging these NSX routers, to ensure that we can have rapid deployment, security according to the definitions we create, and because of that NSX API, we can automate this as well. I can't wait to deploy this with you. I hope this has been informative for you, and I'd like to thank you for viewing.